is now time for our keynote speaker to deliver his session. So Tyler is there you are. Hey, Tyler, how are you? Good morning.
I'm good. Thanks for having me.
Thank you. All right. So we are headed into our keynote, Building the Future, Event-Driven Architectures and Intelligent Applications. For this session, I'm excited to introduce you, as I kind of just did, to our keynote speaker, the CTO at Redpanda, Tyler Akidau. Tyler is a veteran data and streaming architect with more than 20 years of real-time data systems. He currently leads product development at Redpanda, where he's driving innovation in streaming and agentic AI services for the enterprise. Prior to Redpanda, Tyler was a distinguished software engineer at Snowflake, focusing on stream processing and dynamic tables. He also spent over a decade at Google helping build foundational stream processing systems. Along the way, Tyler has become a recognized thought leader. He's the author of Streaming 101 and Streaming 102 blog series, as well as the book Streaming Systems from O'Reilly Media. Thank you for joining us, Tyler. And now we're going to start the presentation.
Hi, my name is Tyler Akidau. I'm really happy to be here, and I'm excited to talk with you about building the future with event-driven architectures and intelligent applications. And I had originally envisioned this talk being very focused on streaming, like for the sake of streaming. But I think it evolved into something a bit more focused on agentic AI. And I think as a forward-looking talk, it's actually maybe a little more interesting that way. So hopefully this is still useful for you as I kind of discuss my observations as we ourselves head down kind of this path of learning and leaning into agentic AI. Before I start, I should give you a little bit of context about who we are. We at Redpanda build streaming systems for some of the largest and most mission-critical workloads in the world. We run at incredible scale with incredible efficiency and utilization, and do so with basically the lowest latencies you can find. And so we really pride ourselves on building rock-solid systems and just solving problems in a very simple but interoperable and efficient and safe way. Really, at a core, there's kind of three main products that we sell. One is our the kind of the classic Redpanda streaming system, which is a Kafka compatible storage layer used for low latency, durable messaging. We also have our Connect offering, which is a suite of 300 plus connectors to all sorts of enterprise data sources and sinks. And then we have our console, which is a Kafka-compatible UI for interacting with and managing and observing your Kafka systems. And it works with any Kafka. So we have a ton of users across all sorts of competing services and open source as well. So that's kind of us in a nutshell. As for myself, briefly, I think it's useful to have context from who you're talking to, especially we're talking about AI here. I basically want to call out, like, I've been doing streaming for a long time. I've had the fortune to write a bunch of interesting stuff about it. I've written a few blog posts, written a book. I've been able to help author a number of academic papers. So it's a lot of experience there. On the AI side, you got to start somewhere. I use ChatGPT to make that image, so that's something. But I think also when you're talking about agentic AI, everyone's experience is kind of measured in terms of months at this point. So, we're all on a nearly level playing field here. As far as where we're going to go, this is the high level agenda. I'm going to spend a little bit of time talking about what agentic AI is. Briefly, we'll touch upon kind of the opportunity of it. Then we'll start to dive into what some of the challenges are. And then most of the talk will be focused on me kind of just giving my thoughts on, like, what are the ways that streaming can help? And it's been interesting for me as I've kind of started to wrap my head around AI, just seeing how many of the problems that I see people solving and trying to figure out what the right way to do things is in the agentic realm, how many of those just really feel like streaming problems. So to kick it off with, what is agentic AI? I mean, if you're really new to it, I would highly recommend reading this Anthropic article called Building Effective Agents. I think it lays things out pretty nicely. They're very specific in how they kind of define what an agent is, and they say that there are, from their perspective, there are two specific types of AI agents. There's one is workflows, and two is what they call agents. Workflows are basically human-coded workflows, human-coded orchestration that utilizes LLMs in some way. So you've got some process you've written out into a program, and along the way, it's calling into LLMs, more like function calls in some sense, saying, "Hey, here's a part of my workflow. I want you to solve it for me." And then agents, as they call them, are fully autonomous. You've got an LLM, you've given it some sort of a prompt, and you say, "Hey, go do this," and it's really fully on the agent to figure that out. By their definition, both are agentic systems, and that's fair. For my purposes, my attitude is an artificial intelligence performing work is an agent. Like, I don't care if it's part of a workflow. I don't care if it's fully autonomous. Either way, I'm going to call it an agent. So if you hear me saying agent, that's what I mean. But I still highly recommend that Anthropic article. It's a very good read. So here's this relatively simplified view of what an agent is. At the core of it, as I kind of mentioned, there's an LLM or maybe a workflow built around LLM. And it's got some number of inputs coming in on one side, some number of tool calls being made to gather context, to retrieve additional data. This might be to some kind of a vector database. It might be to a SaaS service. It might be to some OLTP store or an OLAP store or something like that. Typically, they're going to go, at this point, I think typically things are going through a tool layer, kind of like MCP is an example of a standard that has emerged shockingly quickly and taken hold. But you can just hook these things up to your data sources as well. You don't necessarily have to go through something like MCP. And then there's outputs on the other side. And that's kind of the long and the short of it. The interesting thing that I would point out here is it already kind of starts to look like a streaming problem. You think of streaming actors, you've got inputs and outputs, and they might make some number of RPCs or have some sort of state in the middle, but basically looks like a streaming sort of a system. So keep that in mind as we forge ahead. But next up, let's talk about the opportunity. And my take here is that AI has already materially changed the way we live. I use it a ton in my day-to-day life. A bunch of people I know use it, and it just enables things that you just literally could not have imagined before in the past. And I think extrapolating forward, I really think AI agents are going to materially change the way that businesses are run going forward. Many articles on this, but I think there's a bunch of people who generally agree every business interaction will likely be mediated by AI in some way at some point in the near future, within the next 2 to 5 years. I think it's largely not a question of if at this point. It's more when, how, and who's going to figure out how to do it. And so that leads into the challenges. The challenges are, if you look at the way that AI is doing today in the market, the consumer AI market is flooded and is largely successful. You've kind of got the big players. They've really established themselves pretty well, and things are going well. But the enterprise agentic AI market is not doing great. And I think the reason for that is that agents are super easy to build. Some like Claude Code, you can throw together a useful agent in an afternoon. But deploying them and running them safely in your private networks on private data is still really hard. And so that's the challenge we face. And there's a lot of reasons for that, but I'll talk through some of them. But first, I want to talk through kind of the one that I like to really frame up front, because I think it helps set the tone for what are we dealing with here? If I'm giving this talk live, I would ask the audience, how many of you ever played Dungeons and Dragons? Shockingly to me, I asked this at our sales kickoff, and I got 5 or 6 people, and then I asked a similar question at a purely tech conference with about the same number of people. I thought for sure I would have dozens. I had 2. It was amazing. So go Redpanda sales. Anyway, Dungeons and Dragons has this thing called an alignment chart. It's a 3x3 grid, as you see here. And basically, from left to right, it's kind of capturing the notion of like on the far left, you've got lawful, and on the far right, you've got chaotic. So lawful is, you're law abiding, you want to follow the rules. Chaotic is, you just kind of do whatever you want. And then from top to bottom, the top you have good, at the bottom you have evil. And good is basically selfless. You're altruistic. You're wanting to help others. And evil is basically selfish and kind of wanting to do whatever you want for yourself. And so they use these alignment charts to kind of say, as you're trying to describe how a given character might behave in a situation, you're like, well, I'm playing this character and they're chaotic neutral. So like they're not gonna, they might help you, they might not, but they're gonna be kind of crazy. And so the thing I like to use this chart for to help describe the challenges with AI is, with AI agents, really, we're basically moving to where we're trying to treat them as digital employees in some sense. Like we have a human workforce today. We want to move into a world where it's this hybrid of human and machine workforce, human and AI. But if you think about how we handle hiring for humans, like we've got these long processes that are really involved to pick people that we want to hire. Like, it starts out with there's a job listing. You got to have certain prerequisites, certain things that you've shown you've been able to do that kind of winnow down the set of people that are even going to be considered, right? And then you run them through a whole bunch of interviews, kind of lightweight interviews to begin with recruiters, and then they'll come and talk to people who are actually in the positions, or the managers, the leaders who are leading the effort. Like, there's all sorts of energy that goes into trying to hire humans. And a big portion of that, besides making sure they have the domain knowledge, and that's a very human thing to have to sort of weed out. But you're also trying to get a sense of what is their culture fit and what are their behavioral tendencies. And the goal really is to try to land them up in that lawful good corner. In reality, I think we generally find that human employees are going to land somewhere in that top left quadrant, probably. Like you want lawful good, but not everyone's lawful good. And frankly, like everyone in like the lawful good down to true neutral is generally going to work out pretty well in the work environment. And if you're looking at like at least some of the tech companies I've worked for in the past, we ended up with a lot of chaotic good folks as well. And those companies are able to kind of roll with it, and that works fine. But you're generally trying to weed out like all of the evils and as much of the chaotics as you can. When we start thinking about introducing this agentic AI digital workforce, the reality of where we are today with these things is like they're just living in that chaotic column. Like they're just hanging out there. And the model companies are doing their best with the way they're approaching training and the guardrails and all the stuff that they build into them. They're doing their best to push things up towards lawful good, but like they're so far away from that. And so the best you're really going to get is chaotic good. And in practice, it could land anywhere in that. And so that's, I think that's sort of at the core of like the problem that we're facing with AI agents is how do you then take what is essentially a extremely clever, extremely capable digital workforce who's directly plugged into your system and happens to just be chaotic as all get out and effectively integrate them into your business. That's agentic AI. Beyond that, though, there's a whole bunch of other challenges. Effective enterprise AI requires a bunch of non-trivial moving pieces. You need to be able to build context and maintain it. So like agents need, they're trained on a whole bunch of data, right? But I think, the training takes so long and it's so involved that by the time they're trained, their data set is out of date. Plus, they're trained on public data. They're not trained on your private, internal data for good reason. And so in order to be effective within, kind of the confines of your private business, they need additional context. And they also need, you're wanting them to access, act directly on behalf of your business. If they're working with like an HR database, they're going to need access to that HR database, right? So they need context there. So you need to be able to build up that context for them. And you also need to be able to query that context. They need to be able to access it and say, hey, I'm looking for, HR data for employee X. I'm working on behalf of employee X. I need that data so that I can know, I can make some decisions. You need auth. you need to make sure that they're accessing the right data. Like, again, using the sort of HR agent example to begin with, if the agent's acting on behalf of employee X, like, you don't want them accessing everybody else's HR data as well and being like, oh, well, by the way, let's talk about Billy's salary here. Like, you need to make sure that they're all, only authorized to access the right amount of data, only authorized to make certain changes, and that the authorization is really very strictly bound to any given specific instance of an agent. Very closely related to auth, kind of in the more general sense, you need governance. You need to make sure that when the data is being accessed, like, the right things are coming in. You need to ensure that, if they shouldn't be seeing PII, you shouldn't be giving them PII. If a given agent is doing work that all needs to stay within a given country, they shouldn't be grabbing data outside of the country or exfiltrating data to another country, these sorts of things. Another challenge with AI agents is the fact that these things are basically opaque boxes. Like, you can't debug an LLM and be like, okay, well, it did this weird thing. Let's go look at it and figure out why and fix it. Like, they're so organically grown effectively that you don't have any recourse other than to look at everything that went into it and say, okay, these are all the inputs. This is what caused it. How did we get here? And so this is where auditing becomes really important. Historically, when we've dealt with auditing, we tend to focus on auditing metadata and saying, okay, well, we captured the fact that user X accessed this database at this point in time. You're basically creating sort of breadcrumbs to let you know who touched what or who looked at what, but you don't record everything because it's impractical and it's kind of not usually necessary. But if you're looking at the world of agents where you're wanting to be able to debug what these things are doing, and the only context you have is like the data that went in, the context data that they asked for, and what came out, you actually need to audit everything. You need to record all of the inputs and all of the context retrieval calls. That's a lot of data. Another thing that you need is replay and validation. It's very closely aligned with auditing, but as you're trying to deploy new agents, you need to be able to say, okay, I've built an agent. Here's a data set that I think describes, or maybe multiple data sets that describe what we want to have happen with this thing. Let's run them through the agent and see what happens. That is one of the beautiful things about these agents, is that you can effectively clone them, infinitely, and you can rerun things through them as much as you want, as much as you can afford the GPUs. And so replay and validation is a really important way to be able to ensure that the agents you're deploying are behaving the way that you want, and that you're getting the kinds of actions out of them that you're hoping you will. Not lastly, routing is another challenge you have here. I call it out mostly just because, again, in this context of, like, if you think about what agents are really good at, they're really good at kind of complex data integration or complex sort of problems that require complex thinking. They're also kind of expensive. I kind of alluded to the GPUs thing previously. They're not cheap. And so you're generally not going to want to shove like gigabytes of stacking of data through an LLM or through a bunch of LLMs unless there's some serious value there. And so I think there's a bunch of use cases where you're going to end up wanting to route data, kind of to multiple different types of systems, trying to really send to LLMs the stuff where their unique capabilities are going to give you value, and maybe using cheaper, more classical methods like heuristics or ML models in other use cases. And lastly, multi-agent coordination. Like, if you really, you can do a lot with a single agent, but there's a bunch of use cases where you start to want to have multiple agents working together. And in these cases, you need to coordinate them somehow. They need to communicate. And so this becomes an important problem. And so, and this is not an exhaustive list. This is kind of, I think this hits a pretty good number of the things that you need to think about that are going to challenge you when you're building agentic AI. But there are more than this. But just looking at this, the thing that really struck me as I was kind of bringing myself up to speed on all this stuff is, like, 80% of these are actually data streaming problems. Like, I'm going to talk more about this in the solutions, but a lot of this is really streaming at the core. And so that's kind of what I want to go through. I'm going to next go back through each of these in turn and give a little more insight into like just how does data streaming apply here, and how can you better solve your agentic AI needs by applying data streaming principles. And so that brings us to the last section here, ways that streaming can help with agentic AI. So we'll start with context building. As I described earlier, the main point here is you've got to build up data sets. You've got to have data available for these agents to query that helps give them the context they need. Maybe you're building up vector DBs that are essentially kind of augmenting the model itself by building up knowledge based off of internal wikis or internal data sets. Or maybe they just need to query SaaS systems because they need to access the live data in production or local databases, or maybe you're wanting to take your OLTP databases and CDC them into an OLAP database where the LLMs can kind of run some analytical queries without knocking the OLTP database over. All of these are things that are really right in the wheelhouse of streaming. Like no one's going to look at this and be like, I don't know, would you use streaming for that? Like this is really a classic streaming ETL sort of a thing. And so this one's kind of a no-brainer, but it's worth calling out. Like, yes, streaming is very useful in this context for agentic AI. Moving forward, the next one, this one is maybe less obvious, like governance, making sure that the agents have access to only the data that they need, and that they also only make the mutations or take the actions that they're allowed to take. It doesn't need to be a streaming problem. But in the context of broad data connectivity, it's actually a really nice way to approach it. Because if you think about it, like agents, a lot of the use cases where agents are very helpful is these kind of complex integration use cases where you're like, well, the agent's going to access this vector DB that I built that gives it a lot of knowledge about what we do internally, and I'm going to give it access to some of these SaaS systems that we have that's going to give us customer data or other things that we have in there, and then we've got some local OLTP databases that maybe they need to make changes in. Plus, there's an OLAP database sitting over here that they might need from time to time. When you start to add more and more of these pieces together, and you're thinking, well, how do I govern this consistently? Or like, how do I make sure that a given agent is able to access only what it's allowed to and what it's not? The idea of trying to enforce that at every data source is actually kind of intimidating, because policy consistency becomes a huge challenge. You now have to make sure that the way that your agent is kind of interacting with each of these systems is done on a one-by-one basis. And so this is where streaming and governance start to kind of intersect really nicely. If you have a single agentic data plane built on a consistent streaming system that allows you to uniformly apply governance across all of those interconnection points, it makes it vastly easier to establish common enforcement policies that are just applied at the right places and the right times. And so streaming in this context of agents really becomes a very useful pattern for enforcing governance, even if it's not the only way to do it. Next up, I want to talk about auditing again. As I'd said before, one of the most important things you can do when deploying agents in order to allow you to figure out what the heck happened after the fact is to create audit logs of everything going into and out of these things. So all of the inputs going in, all of the calls out to tools, all of the data returned by those tools, and all of the outputs going out of it. You can't just log the metadata. You actually need the data. And this can be a lot of data. And a lot of systems aren't really built to gather this sort of data at the throughputs and the latencies that you would want for this sort of scenario. But streaming systems are. And this is the thing that streaming systems do really, really well. And so this is another place where streaming, it just turns out, is actually a really great paradigm for how you approach productionizing AI agents in the enterprise. Very relatedly, as I mentioned previously, replay and validation are essentially sort of the same concept as auditing, kind of in the other direction. And so as you're developing these AI agents, you want to be able to say, hey, we've got some test data maybe, or maybe we've got some production data that we've recorded. And these are actual logs of things that happen, and we want to see what would this agent do on top of these. Replay and validation lets you go through and actually shove that data through the agent and see what comes out. And so it's a really nice development paradigm for iteratively building and improving on your agents without having to test in production. So again, streaming systems have been built to kind of meet the latency and the throughput and the scale needs for these kinds of use cases. Next up's dynamic routing. So LLMs are fantastic. They do amazing things, but they aren't a fit for every problem. At least, not today. Maybe we'll get there to someday, and we'll all just sort of be obsoleted by LLMs. But for now, they're expensive, and you don't want to just provide unfettered access to private data. And so there's a bunch of use cases that we've come across that really can be augmented by LLMs, but you don't want the LLM to be the only thing involved there. And again, this is where this kind of a streaming paradigm of the idea of like the streaming microservices or actor-based approach to streaming is a really nice fit. Because like to take the example here on the slide of fraud detection, companies have been investing heavily in fraud detection, both with heuristics and with ML models for a long time now. And they're fairly sophisticated at it. There's obviously a bunch of places where they don't succeed, but you can kind of treat it as a bit of a high pass filter, and it's quite effective. And so a good approach is to say, okay, well, we've got our fraud detection models, and maybe in the past we would have relied entirely upon them and said anything that kind of meets this, like anything below like the 99th percentile we would just throw out. But now in a world of having LLMs, you can consider saying, okay, well, we're going to be a little more picky, and we're going to say we're going to maybe catch some things that we think that the ML model thinks might be okay, but they're kind of on the fringe. And rather than just allowing those things to go through, maybe we'll send those to a fraud detection agent, this LLM. And so the cases that are a little more of a gray area, you send those off to the LLM and let it apply its greater intelligence and its greater breadth of context to make hopefully a better decision. This is again a very classic sort of a streaming use case of routing data and splitting it up, and you want to have kind of a nice separation between these systems. You don't want them all to hold each other up because they've got RPCs that they're blocked on, and so this is another place where streaming brings a lot of value to deploying agentic AI effectively. And then lastly, multi-agent coordination. So multi-agent scenarios need, very similar to what I was talking about last time, they need scalable, decoupled communication. A good example of this is, you've got an agent you built, and you want it to make some decision. It's gonna decide that, like, a given user is safe, or a given thing is fraud, or maybe it's something a little more complex and a little more potentially directly business, directly good or bad for the business, depending on how good of a decision it is. Maybe it's deciding to give someone a loan or deny them for a loan, for example. You can just hook that agent up and YOLO with whatever it comes up with and say, okay, we think it's good, we'll figure it out. But if you really care about the results, a better way to do that is to build a multi-agent system where you've got an agent who is sort of trained on all the appropriate data, has all the context, and decides, okay, I would like to propose that we do give this person the loan or don't give this person the loan. Rather than just acting on that directly, you then hand that decision off to one or more validation agents, which are built and prompted and trained to look at these decisions and look at you probably have the decision proposer agent also provide the reasons why, sort of the context for it. They're trained to look at it and say, okay, does this seem like a good decision or not. And you might even use different models for each of these validators, because each model kind of has a different set of things that it either is good at, or there's kind of poison pill types of prompts that you can send them that make them do either make bad decisions or just kind of spit out garbage or whatever. And so by using kind of a small swarm or a small fleet of different validators, you can say, okay, well, we'll send the proposal to them. If all three of them agree, this probably looks pretty good. Or you'd have to decide, like maybe it's 2 out of the 3, or maybe we've got 5 and you take 4 out of the 5, whatever. But you come up with some decision for, like, when this condition is met, we feel pretty confident about it. And then all of those agents forward their decision to a final agent that is in charge of actually applying this action, whatever it is. If you hook all these things up directly, like, again, it doesn't scale well. You end up with back pressure issues. Having a streaming system in there that allows you to decouple them and let them work somewhat asynchronously from each other just makes for a more scalable and more fault tolerant and more reliable system. And so that's basically everything I wanted to cover. I guess to wrap it up, one last thing: streaming isn't everything. I mean, there is a whole bunch of stuff that you need in an agentic AI world that streaming isn't going to cover for you. You need authentication and authorization. It's not really a streaming problem. You probably need a multimodal catalog of contextual data. Like, most streaming systems are not like a catalog of things, including like your data lake and your OLTP servers and your OLAP servers and your SAS servers. You need to be able to you need the ability to query data and retrieve data. It's sort of adjacent to streaming, but it's not a streaming problem. If you're writing workflows directly, you need some form of durable execution for these. Systems like Temporal or Resonate or DBoss, because you want to be able to write workflow. These are going to be long-running workflows. They're effectively, they're kind of like, the selling point for those systems prior to AI was, they're great for human interactions. They allow you to write these workflows that run for a long time, and maybe you have to wait on a human making a decision. You get the same effect for agents, and that's really valuable. And I'm sure I'm missing a whole bunch of things that would be nice to have. But nevertheless, streaming is a key foundation of the agentic data plane. And I think it was sort of surprising to me to just see how much it is. But I think hopefully this has been helpful and kind of helps you formulate, as you think through your plans of how you want to address agentic AI in the future. Hopefully this helps you kind of map that out. Thank you all for listening. This QR code should give you a link to the slides if you want to see them again, or see any of the URLs that I was blocking by myself. And thank you all for listening. Appreciate it.
Thanks, Tyler. And I forgot to mention in the intro how we got acquainted with Tyler. So the streaming integration platform utilizes Redpanda, and Jeff Green picked it in particular because of its low latency. And so we thought this would be a good partner for our keynote. So thanks again, Tyler, for agreeing to do this. We've got a couple questions. I'm going to start with some that I have. One of them is, how do you see agentic AI changing enterprise software delivery and business models in the next few years? We're hearing some typing, and I don't think that's you, Tyler. So anyway, sorry. Did you catch that question? And
Yes. Yeah. So I think that the big thing, I think, going forward is we see a really big shift in how applications are developed. Like, a lot of development today is engineer driven. And that's not to say that engineers are going to become obsolete. I think particularly in systems infrastructure and things like that, they're going to continue to be really important. But AI agents, or AI in general, is kind of raising the abstraction layer one more time. If you think back, decades ago, people had to code in machine assembly language, and then we got compilers, and that kind of allowed you to build larger systems beyond that. And then we've gotten more and more sophisticated languages over the years. AI is really taking it one step further, both in that engineers, can kind of leverage the capabilities to move faster, do things, more effectively. But I think the really big shift is that you're going to see a lot more application development happening from non-engineers because it just becomes possible. It's scary, but it's also just like it's crazy exciting. Like it's been fun. It's been fun watching kind of within Redpanda as we're trying to adopt agents more pervasively. Just how excited people get about being like, I can just talk to this thing and be like, I want you to do this on this data set, and here's what the results should look like. And it goes and does it. And kind of as I said in the talk, like they're chaotic still. So there's still this kind of, we're still kind of figuring out how to do this effectively. But once you kind of get it nailed down, like it's just amazing what you can do by just talking to this thing. Like it's really like having a very smart and very plugged in, coworker who you can sort of say, hey, can you do this for me and do it 24/7 and do it really fast? And so I think that's going to be the big shift, is that there's going to be a significant amount of application development, what we'd historically think of as software development, that kind of moves more broadly into the various disciplines themselves who are going to be utilizing this, because it's just so easy to describe to an AI, this is what I want to do, and it'll make it happen.
All right, here is my next question. What is the biggest challenge enterprise teams face when running agentic AI safely on private data?
I think from my perspective, the biggest challenge is the fact that enterprises have such a technological sprawl across all the systems they have. And so in order to, you've got to safeguard the accesses to those systems, and you want to do so uniformly, but just the sheer breadth of systems that most enterprises have make it a challenge. And so that's kind of why I've advocated in this talk of if you're going to connect them all together with a streaming system anyway, in order to kind of move the data to the agents, that becomes a natural place to do it, because otherwise it's just, it's a lot of work and a lot of, feels like whack-a-mole of trying to how do we safeguard every system and make sure we do it consistently.
Yeah. Joel, Tony took the question. Okay, good. I took Tony's question. Okay. So Joel had asked if you had a link to your book and podcast, and I had a question about your book. If you had an O'Reilly book, did you get a fun animal on the cover? And if so, what was the animal? Oh, somehow you got muted.
Sorry.
Here you go.
I got muted and then I had to find the mute button.
Okay.
I did. I think it's a brown trout, if I'm remembering correctly. So fun, maybe not fun animal, but I got an animal. You're assigned an animal is the thing. I didn't get to choose.
Okay. Good to know the inside workings.
Yeah, if you do get the book or just see it in the bookstore and look through it, there is in the preface, I did my own version of the cover that had the animal I wanted. So you can kind of check into that and see. Because I was not super happy with the brown trout. So
what animal did you pick?
It's a robotic Tyrannosaurus Rex with a Scottish accent.
Okay. Awesome. I wish that they had picked that. That's more fun than a fish. I think that wraps up our day one. Thanks so much, Tyler, for agreeing to participate with us this year. We really appreciate it. So
my pleasure. Thank you for having me.